We'll proceed in pseudo multivariate calculus in area vector. Pseudo multivariate calculus, the historical discussion that we are pursuing. Historical discussion in a way that we start our computation through simple mathematics, multiplication, addition, subtraction, and division, and then we end up in the vector calculus. And then we don't believe that it was that simple. Okay, in that way, we are in a phase of calculating the surface area of a sphere. Okay, surface area of a sphere. Mind blowing, amazing. What is surface area of this sphere? It doesn't look like a sphere. Okay, it looks like some war weapon. Okay, or it looks like some asteroid. But trust me, it is a sphere. If I break it, then one sphere will come. That is for sure. Okay, a lot of water is there. So that is the how to calculate surface area of this sphere. What is surface area? Surface area. What is area? Area, I know area. Okay, what you know about area? Area means two dimension. Okay, two dimension means there are two dimensions. What is the length? I know length. Length is one dimension, single dimension. What is volume? I know volume. Volume is three dimension. What is three dimension? What is two dimension? What is single dimension? Single dimension means it only has a length. Length. Two dimension means it has two sides. Single dimension means a measurement which has only one side. That is single dimension. Dual dimension means which has two sides. That is called dual dimension. Triple dimension, three dimension, which has three sides. Okay, if I'm trying to calculate area of this, then it has two sides. It does not have any side. It is a full sphere. Where are the sides? There, the pseudo mathematics hits in. Pseudo mathematics. Can someone believe that we are going to calculate surface area of this sphere so quickly? What is the surface area of this sphere? Okay, which has a width and length. That is the area. How to calculate area? Area of any shape will have a width and length. Multiply it, you will get the area. A simple novice person will tell how I can calculate area. Calculate the width and then calculate the length, multiply it, you will get the area. Okay, calculate the surface area of this. I don't know. Where is your width and where is your length? I don't know. How to multiply it? I don't know. Okay, in that sense, what is the surface area of this vector? Okay, now in that sense, what is the surface area of this? It has two sides. Anyway, now I'll repeat it again. How to calculate surface area means two sides. How to calculate length of this line? How to calculate length of this line? I don't know. Okay, how to calculate length of this line? Okay, one point is origin, for simplicity I am taking. Another point is x comma y. What is the length of this line? Then it is x square plus y square square root. How you calculate it? Okay, so we use Pythagoras theorem. So if I use Pythagoras theorem, then quickly I can calculate the length of this line, x square plus y square square root. Hold on. Length of a line that is square root of x square plus y square square root. It looks like length of a vector that is connecting origin and point x comma y, xi plus yj. Indeed, I can represent this line through a vector xi plus yj. Okay, this looks like the length of a line is nothing but vector representation of a line and then calculating the magnitude give the length of the line. This is the hint I am getting. Now, what is the length of this curve from origin to any point x comma y? What is the length of this? Then I have to represent this curve line through vector and then calculate the magnitude of the vector. We will get it. Certainly, we cannot do through a straight line. If I connect origin and a straight line x comma y, it will give the vector representation, will give the vector representation of a straight line, and calculating the magnitude of the straight line will give the length of the straight line connecting origin and x comma y. Idea is to calculate the length of this curve. Okay, in that sense, what is representation of this curve through a vector? Because I know that if I represent a section of a line through vector, then calculating the magnitude of the vector will give the length of the line. What is the representation of this curved line as a vector? There will be many analogy here. One analogy is that the difference between a straight line and a curved line. We are talking about pseudo mathematics calculus. Means pseudo multivariate. This topic is not available in any of the book. How through normal way I can solve a big problem. So this is research bed that we are pursuing. Now in that fashion, if this connects origin and point x comma y, this is the vector representation. If this is x-axis, if this is x-axis, and if I take the straight line, then everywhere y by x along the x-axis, it is constant. But if I take for the curve, then everywhere y by x is variable. So for curved line, y by x is variable, but for a straight line, y by x is constant and everywhere it is same. So if I represent my vector xi plus yj in term of y by x that is variable, then I can represent my curved line also through vector. Are you joking? How you can represent a curved line through a vector? Because vector means a straight line. Curve is not a straight line. Both are contradicting each other. How it's possible that you represent a curved line through a vector? This is called power of algebra. Okay, for a curved line, the vector will be different. At this curved line, at this point, this is the vector that is tangential. At this point, this is the vector. At this point, this is the vector. At this point, this is the everywhere vector is different. If everywhere vector is different, then set of vector can be represented through algebra. Anyway, now for the straight line, curved line, this is pseudo multivariate calculus. Whatever we have written, it is not going to change now. We will extend to it, but we will extend to it, but we will not modify it. When we said that a line can be represented through a curve, through a vector, that is xi plus yj, it will remain like that only. Now here I have to extend it rather than, sorry, this was for a straight line. There is a different approach for curved line vector. No, I have to extend it. Now here in the curved line, y by x is different. So I'll take out x and it becomes I plus y by x j bracket close into x. Okay, now in that fashion, this is the vector representation of a curved line. I plus y by x j bracket close into x. If I feel my y is different, not y by x is different. Here y by x is different. Like if this is x-axis, if this is x-axis, then I have a, this is origin, this is y-axis. Okay, consider there is a line called x equal to 3. This is parallel to y-axis, x equal to 3. What is the representation of this line? Dy by dx for this will be infinite. In x by y, I can represent that is 0. Means I need to take out y if I want representation in x and y, x by y. Then what is the vector representation? That is xi plus yj. Take out y. It becomes xyi plus j bracket close into y. That is the vector representation. That is the vector representation of a curved line. Okay, anyway, two representation are coming. One is I plus y by x j bracket close into x, and one is x by y I plus j bracket close into y. Okay, as per the primitive calculus, if there is a division and numerator is dependent upon denominator, then it becomes differentiation. And there is a multiplication of two items, and one item is function over another item, and another item is the independent variable, then it is a full case of integral calculus. So the vector representation for a curved line becomes I plus dy by dxj bracket close into dx. Please watch our previous video. Otherwise, it is dx by dy I plus j bracket close into dy. These are called line vector, curve vector. These are curve vector. This is not written in any of the book. Anyone can try. What is the equation of a curve vector? I plus dy by dxj into dx. What is representation of a curve vector? Same thing, dx by dy I plus j into dy. Okay, miss, if I have a, please mind it. This is a $1 trillion explanation. If I have an equation of a vector that represents a straight line, if I take out an independent variable from there, then it becomes an equation of a curved line. What is the vector equation for a straight line? Vector equation for the straight line is xi plus yj. What is your independent component? X is independent. If I consider x as independent component, then it becomes I plus dy by dxj into dx. Or if I consider y as independent component, then it becomes dx by dy I plus j bracket close into dy. Means if I take out independent component, then it becomes a vector representation of a curved line. Can you prove it? What is the length of your curved line if y equal to x square, where from origin to any point x comma y, the vector representation is I plus dy by dxj into dx. Magnitude of this vector will give the length of this curve. Dx means length of the x. Actually, it is I plus y by xj bracket close into x. X is the length of x, that is from origin to x. If I make it dx, then it will come as a limit, and limit is 0 to x. Now, now it is magnitude of this, that is 1 square plus dy by dx whole square root into dx. Y equal to x square is the line. Dy by dx is 2x, 4x square. Okay, it becomes a square root of 1 plus 4x square dx. Now someone can calculate. I believe it will come as tan inverse or something like that. Okay, someone can calculate it. This will be the length. It will not be that straightforward, but this is the length of the line anyway. Now we are in phase of calculating the surface area. We are in phase of calculating the surface area of a sphere. So surface of a area of a sphere in a hybrid coordinate system. If people read any book, then it is written that the if I take a, consider this sphere is centered at the origin. This sphere is centered at the origin, means xy plane will come and cut it at the center, and half of the sphere is above the xy plane and half of the sphere is below the xy plane. Okay, half of the sphere is above the xy plane and half of the sphere is below xy plane, and the center of this will be exactly at the origin, that is 0 comma 0 comma 0. Okay, if that is the scenario, then what would be kind of its surface area? What would be its full surface area? That is under question mark. How to calculate the surface area? If I take any point P here, and from the origin, if I take out one line, that will be a radius line, and it will pass through the P. What is the P? P considered is x comma y comma z. Then position vector will be xi plus yj plus zk. The position vector connecting origin and any point on the surface is x, that is xi plus yj plus zk. From origin, if I draw a line from the origin, this is centered at the origin. From the origin, I draw a line, and that line goes and touch the surface at point P. Then this line is a position vector connecting 0 comma 0 comma 0 to point x comma y comma z. In that fashion, this vector is xi plus yj plus zk. Magnitude of this vector is x square plus y square plus z square square root. That is nothing but the radius of this sphere. Anyway, now idea is, can we calculate the surface area of this sphere through simple mathematics. What is simple mathematics? What is simplest form of it? Simplest form of this surface area is a flat surface area. Okay, because if I wanted to calculate the length of this curved line, if I wanted to calculate the length of this curved line, then I took a straight line. Simple case. If I want to calculate a surface area of a sphere, I'll take a simple case. I'll take a simple case of a simple case of a rectangle. Okay, take a simple case of a rectangle. Okay, this is a rectangle. This is the simplest case. Consider this is this is a rectangle. Okay, this is a this is a rectangle, and this is a rectangle means this is length and this is width. This is length and this is width. How to calculate surface area of a rectangle? Width into length is the surface area. Makes sense? Now, if this point is x1, y1, and this is origin, and this point is x2, y2, then this length is x2 square plus y2 square root. Similarly, this length is x1 square plus y1 square root. That is same as if I represent this as a vector and this as a vector, then multiplication of vector and its magnitude. Makes sense? This vector magnitude is, if I represent this as a vector called a vector, and this if I represent as a v vector, then a vector is x1I plus y1j. B vector is x2I plus y2j. A vector's magnitude into B vector magnitude. The area of a simple surface, rectangular surface, is width into length. Width, width into length. Width is width is a square root of width is a square root of x square plus y x1 square plus y1 square. The width, the height, length, that is that length that is connecting origin and point x2 y2, the length is x2 square plus y2 square root. Now the net area is square root of x1 square plus y1 square into square root of x2 square plus y2 square. In that case, this magnitude is a magnitude of vector, that is x1I plus y1j, magnitude into x2I plus y2j, magnitude. It is same as a vector. If I say that this width vector is a vector cross product b vector. This is called area vector. Then calculate the cross product and calculate the magnitude of it. That means slowly we are proceeding. Okay, now width into length transformed into a vector cross b vector. Whatever the new vector comes, calculate the magnitude of it, that will be the surface area. Direction of surface area will be perpendicular to the surface, where a direction of length vector is along the length. This is the direction of the length vector, not perpendicular. But area vector, but for the area vector, direction will be perpendicular. If area vector is like this, area vector will be perpendicular to the surface vector, because it is one a vector and b vector cross product. Anyway, what is a vector and what is b vector? This is for the flat surface. Now we will go to the, because see how we slowly we are proceeding. This is not a flat surface. This is a round surface. Anywhere if I touch my hand, it will come as round, not flat. It is round. Everywhere it is round. Can you see? Everywhere it is round. Okay, but simplest is the flat surface. If I have a flat surface, then this is b vector and this is a vector. Okay, as I say, pseudo multivariate calculus, as we go along, our fundamental will not change. We will extend it, but it will be closed for modification. Oh, sorry. I wrote it for flat surface, not for the curved surface. I'll change it. No, whatever we are writing, we will expand. This is called the fundamental principle of designing, where you are open to extensibility, but you are close to modification. You cannot change it. So if I say my flat surface area is a vector cross b vector, and if I make it curve, then again now this straight line become a curved line. Similarly, this straight line become a curved line. Again, we will write it is A vector cross B vector only, the cross product. But A vector will be, now it will be vector representation of a curved line, and B vector will be vector representation of a curved line. Now, if I consider A vector is in analogous to the x-axis and B vector is analogous to the y-axis, how you can say like that? Because I am taking pseudo mathematics. Okay, in that sense, what is the A vector? A vector is xi plus yj. I am removing 1 and 2. Cross product with the xi plus yj. Here I have to take out x because it is analogous to the x-axis. And since B vector is parallel to the y-axis, I'll take out y because y is variable there. In that sense, now the curve vector will be represented as I plus dy by dxj bracket close into dx. Cross product with bracket I plus, I'm sorry, dx by dy plus j bracket close into dy. Actually, it is I plus dx, I plus di plus y by xj bracket close x, because if I multiply it by, it becomes xi plus yj only. Okay, in that sense, it's become I plus y by x bracket close into x, cross product with with x by yi plus j bracket close into y, or altogether it becomes I plus dy by dxi bracket close dx cross product with dx by dy I plus j bracket close into dy. If I take three dimension, then it becomes I plus dy by dxj plus dz by dxk bracket close dx. Makes sense? Because one point is the straight line vector is xi plus yj plus zk. If I had taken a point on the sphere, if I had taken a point on the sphere connecting from the origin, that point is x comma y comma z. So primary vector is xi plus yj plus zk. If that is the way, then we have cross product of a vector and b vector to get the surface area. There will be cross product of two vector only because there is surface area. Now we are representing this curved surface area through curved vector cross product, and curved vector cross product one is I plus dy by dx. I have taken x out. I j plus dz by dxk bracket close into dx cross product with dx by dy I plus j plus dz by dyk bracket close into dy. Okay, very nice. Thank you very much. How nicely you converted a straight line vector into curved line vector by taking out x or y. Okay, we have seen it. Now we are discussing about, I know that in a spherical, can we solve? It will be very complex, I believe. It will be complex in Cartesian coordinate system. Can we solve it through a spherical coordinate system? That is under discussion. Can we solve it through a spherical coordinate system? If I want to solve it through a spherical coordinate system, there is pure spherical coordinate system where I, j and k, we are saying xi plus yj plus zk is the coordinate for the Cartesian coordinate system. I, j and k will be changed into r unit vector, theta unit vector and phi unit vector, because three component of a spherical coordinate system is r, theta and phi. But there is a hybrid model, that is whatever just now I talked, r unit vector, theta unit vector, phi unit, that is also not available in any of the book. The book that talks about the spherical coordinate system, that is a hybrid model, where we say that xi plus yj plus zk, that is in Cartesian coordinate system, can be changed into spherical coordinate system where x equal to r sine phi cos theta. Please refer to any book. Y equal to r sine phi sine theta, where z, that is the height, is r cos phi, where phi is angle from the vertical. Okay, phi is angle from the vertical, where theta is angle in the horizontal xy plane. Okay, xy plane, and r is the radius of the sphere. In that sense, r sine phi cos theta I plus r sine phi sine theta j plus r cos phi k, this is the position vector of a straight line, if I represent a straight line through position vector, then it is becomes x r sine phi cos theta I plus r sine phi sine theta j plus r cos phi k. Okay, now what is the surface area? A vector cross B vector. Now here the two things that is variable here is theta and phi if I talk about surface area of the sphere, because r is constant everywhere on the surface area. The radius from the center is constant, that is for guaranteed. Only thing varies is theta and varies is phi. If that is the case, that theta and phi varies, then in two cross product, I'll take out theta and one side I'll take out phi, and it become a vector representation of a curved line. Mind blowing, amazing, $1 trillion kind of scenario. If I have a vector representation of a straight line, that is xi plus yj plus zk, and I can make this vector representation of a curved line by taking out x or taking out y, because x and y are independent variable in 3 dimensions. Z is dependent. Okay, similarly, if I have a vector representation of a straight line, that is x will be replaced by r sine phi cos theta, y will be replaced by r sine phi sine theta, and z will be replaced by r cos phi. So straight line representation in hybrid spherical and Cartesian coordinate system is r sine phi cos theta I plus r sine phi sine theta j plus r cos phi k. Now the surface area vector is the cross product of two curve vector, two side vector A cross B, where A is r sine phi cos theta I plus r sine phi sine theta j plus r cos phi k, cross product with again r sine phi cos theta I plus r sine phi sine theta j plus r cos phi k. One side I'll take out theta and another side I'll take out phi, making it a vector representation of a curved line. Makes sense? In that sense, one will become r sine phi d cos theta by d theta I plus r sine phi d sine theta by d theta j plus 0, because d of r cos phi by d theta will be 0. Phi does not vary with the theta. R is anyway constant. Cross product, bracket close d theta. Cross product, and now I'm taking out phi out there. d d r d r cos theta d sine phi by d phi I plus r sine theta d sine phi by d phi j plus r d cos phi by d phi k, bracket close d phi. If I calculate this cross product and then d theta d phi, where phi is from 0 to pi, because vertical angle will vary 0 to pi and theta will vary 0 to 2 pi. In that case, theta is 0 to 2 pi and phi is 0 to pi, where I have to calculate this cross product and then calculate the magnitude. We will calculate, I am not running away. We will calculate the cross product for it. What is the cross product for it? Now we have r sine phi, r sine phi minus sine theta after the differentiation. R sine phi minus sine theta I plus r sine phi cos theta j. This is at one side. Other side is r cos phi cos theta I plus r cos phi sine theta j plus r minus sine phi k. Now settle down. Now I and I cross product will be 0. I and j cross product will be k. Okay. I is r sine phi minus sine theta, and that side r cos phi sine theta. It becomes minus r square sine phi cos phi sine square theta. K. K. Okay, let's leave I and k multiplication. Now start with the j. Ji will be minus k. J is r minus k. Already we have minus there. Now r, here it is r, j component in first one is r sine phi cos theta, and here r cos phi cos theta. It will be r square sine phi cos square theta minus and minus k vector. In that sense, it will become minus r square sine phi cos square theta plus sine square theta will go away. Now k vector will be minus r square sine phi cos phi, that we will keep it. R square sine phi cos phi k vector minus. Okay, let's settle down other one. Now here I and k cross will become minus j. Okay, one side is r sine phi minus sine theta and one side is r minus sine phi. Okay, and I cross k will become. So altogether minus is already there and one more minus, it will remain as minus 1. Now in that sense, it will become r sine square phi cos sine theta, r sine square phi sine theta, I and k, j vector. Okay, j vector r sine square phi sine theta. Similarly, other side it will become, if I settle down ji we have settled down, j and k it will become j and k, it will become I vector, but minus is there, it will become minus. And this side it is r sine phi r square sine square phi r square sine square phi cos theta. Okay, one I did I and k and it become r square sine square phi sine theta. Okay, one is r square sine square phi cos theta. Now altogether we have r square sine square phi sine r square sine square phi cos theta I, r square sine square phi sine theta j, r square sine phi cos phi. Now if I calculate magnitude of this, then r square, let it come out, then it becomes sine to the power 4 cos square theta, sine to the power 4 sine square theta, and then sine square phi cos square phi. First two will become sine to the power 4. Sine square theta cos square theta will go away. Sine to the power 4, sine to the power 4 plus sine square cos square theta. I believe it is all right. Sine to the power 4 plus sine square plus sine square sine to the power 4 plus sine square, I'm sorry, sine to the power 4 sine to the power 4 sine square phi cos square phi. If I take out sine square, then it will become 1 plus cos square phi. I believe it is all right. Okay, it will become 1 plus cos square phi square 1 plus cos square phi. Okay, altogether it will become r square is anyway kept outside sine square. It should become 1. Somewhere I am making mistake. It should come out as r square sine phi. Okay, someone can try it. Okay, it should become r square sine square phi. I'll try it again. Okay, so what we started with the r square sine square phi, r square sine square phi cos theta, r square sine square phi, r square sine square phi sine theta. Okay, and then r square sine phi cos phi. This is what I remember. Okay, if I take a square of it, anyway, r square will come out. Okay, now in that sense, if I take a sine square phi cos theta, sine square phi sine theta, I, j and k is sine phi cos phi. Okay, now all square I have to take and then square root. Okay, in that fashion anyway, sine phi will come out. R square sine phi will come out because it is everywhere. Now it will become now sine phi cos theta I plus sine phi sine theta j plus I believe cos phi. Now it will become sine. Now it will become sine square phi, sine square phi cos square theta plus sine square phi sine square theta plus cos square phi. First two will become sine square phi and cos square phi. One square root gone. Okay, at the end it came as r square sine phi. R square sine phi d theta d phi is the net surface area. R square, R is constant for the full surface area. R I can take outside sine phi d theta d phi. Sine phi integration is minus cos phi 0 to pi. It will become 2, and d theta integration is theta 2 pi. Okay, 2 pi 4 pi r square is the surface area of a sphere. Mind blowing, amazing. What is the extra thing we did here? The extra thing what we did here, that we took a straight line vector and take out one independent variable from the vector. It becomes a vector representation of a curved line. The way we did. A straight line vector is xi plus yj plus zk. Take out x and then it becomes I plus dy by dxj plus dz by dxk, bracket close into x dx. It becomes a vector representation of a curved line, because dy by dx and dz by dx, these are algebraic differentiation. It will be different for different shape. Similarly, if I had r sine phi cos theta I plus r sine phi sine theta j plus r cos phi k, take out theta and it becomes a vector representation of a curved line. Take out phi, it will become vector representation of a curved line. Do the cross product and just enjoy. This is amazing, mind blowing. This may create a revolution in the sense that with simple way, line vector, area vector, width into length, and x square plus y square root the length of a line, we calculated the surface area of a sphere. Can we calculate the volume of a sphere? What is the volume of a sphere? Volume means surface area into height is the volume. If I take a sphere, if I'm trying to calculate the volume, the surface area vector dot product with the radius vector, that is the height here, will give the volume. Can someone proceed here? Calculating the volume of a sphere. Volume of a sphere is surface area of a sphere. Surface area vector of a sphere. This is surface area vector of a sphere, where everywhere it is different. And that surface area vector sphere is along the radius vector. So surface area vector dot product with the radius vector, or area into, if I have this area, this is the area, this is the area. If I multiply with the height, then it will give the full volume. Make sense? Area into height is the full volume. Width into length is the area. Area into height is the volume. Now we have surface area. What is your surface area? That surface area vector is r sine phi minus cos r sine phi minus sine theta I plus r sine phi sine theta j plus r plus 0. That cross product, I'm sorry, r sine phi minus sine theta I plus r sine phi cos theta j, bracket close d theta. Okay, cross product with r cos phi cos theta I plus r cos phi sine theta j plus r minus sine phi k, bracket close d phi, d theta d phi. This is the area vector. If I do dot product of this area vector with the radius vector that is perpendicular to the surface, then will it give the volume? Can someone try? Consider this as an assignment and calculating the volume through this simplest approach. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.